Okay. Well, good morning. And it's Marco Bernardo, correct?
Exactly, this is my name.
Yes. And if you could give me just a brief description of, I'm looking at sunmade.org and your exciting project where you're recycling plastic using solar thermal and human powered technology. Yes, give us a description.
So this is the goal. I'm a mechanical engineer, and I'm Swiss and Portuguese. I have both nationalities, and I finished my studies in Geneva. I start working in a 3D design, and but like big companies making watches, every people who went in these companies since 2006 and 2008, I give them all the tools to make machines and express the ideas in 3D. This is the first part. And work also in another area like the heating pumps. It was at the beginning.
Sure.
And once a time in my life, I needed to be more sustainable for my gratification after work. And I decided to go to Africa. So there I went to Burkina Faso and I met someone and we built a bakery. We make 4,000 bread a day. That's cool.
Yeah.
And then back to Geneva again. Now we are like in 2011. And I approach the solar community there and I begin to work more with the solar power and still working in watching companies and making something in the industry. And once I was like, I want to roast the coffee, but I also want to make a lot of things because the sun is cultural. The culture, people don't see the power is here. It's just here coming a lot. And uh, I need to make something. And I met someone from Plastoc in Geneva who used to make plastic recycling. So I went to see him and and I said, I think I can melt plastic. And together we make the first plastic injection in Geneva in 2020. And after that, I decided to come to Portugal. I built my own house with my hands, and now I have my atelier. And it's the beginning since a few months of what I want to do. I go to the beach. I can recognize the plastics after 2 years of experience. I just take them, and then I choose the colors. I cut by hand. I put inside my machines, my machinery, and I inject the objects. And like this is a cassette. I didn't make this one, but I make this one.
Oh, wow. Sure.
So my way to do the things is to be open source. I know that if you help someone, someone will help you. So, and I run this also with the solar community because I went to Console Food
Sure.
in the south. So the Sunmade project is an open project for each one who can make some tools and cut some things to make machines to have their own recycle machine. You can go through the beach in the developing countries to sell this. This you can sell it very high because it's a whole object. And inside I put some microchip. It means when you put against your phone, you can have informations like imagine the artists selling the albums like this. They use the waste on the beach to sell their art. This
Sure.
one idea. I have a lot of this. So the way is to make an open source. The first step was to share the kit number one. And I'm working in the number two, but I'm going slowly.
Oh,
But I want to go sure. For the moment, the objects are like this, but I also made some glasses. This is COVID masks.
oh, nice.
And this is HDPE. It's like some things.
Sure.
And since I went to Lisbon, we win a prize in Maker Faire. In 2020 also, we win the prize in precious plastics. And the goal now is to have meetings like this one because I want to be, how to say, my English is like my English, but I want to have some lane because solar people in solar communities, they know how to cut some wood to put some things to have the sun. And they live near some people who are recycling the plastic. And through this channel, the channel of the solar community, we can help the plastic community. For example, in Minnesota, to say your town is very funny for me because we joke about this. I say there is a precious plastics in your town. It means if you bring them the technology and they put the energy together, we just discuss and you make it. It can be cool.
Yes. Well, the everything you have there just appeals to me on so many levels. The first is if you talk to my friends, they'll tell you I'm about as anti-plastic as you can get because of the problems being caused. At the same time, I recognize it's here. It's something that can be used for a good purpose. Uh, we don't need to make any more new plastic. I remember reading about a fellow, I think in Denmark, who came up with some big buoy system to go to the Pacific Ocean to just
Yeah.
start gathering up the plastic. And my thought was, well, you should have kind of a scow or a barge alongside with a big solar melter to melt
Yeah.
them and then melt them into lifeboats and just drop them off the edge and just say free, this is your lifeboat. So whoever wherever
Incredible. Incredible.
no,
Wow.
so and it would remove it from the ocean. There'd be still, there's that will how many hundred years will it take to extract all that from the ocean? I mean, will it ever be 100%? Probably not. But get rid of enough of it so the whales don't end up in the nets that are discarded. The fish don't choke on stuff. The seabirds don't choke on stuff. So just just a primal level for me saying let's attack the problem, recognizing that it is already here and it can be made useful and it be kind of redeemed from the evil
Yeah.
that it has been a part of. And then open source. I think there's probably a half a dozen solar cooker makers that they manufacture on their own and sell, but they also include the plans for them so people can make them on their own. And they are often made with plastics such as windshield reflectors. So the fact that you're freeing up your ideas and the specs to the world is fantastic. Now, what was your thought process to decide to do that? Was that just something you wanted to do anyway, or did you come to that conclusion after trying this out?
Um, my favorite things is creativity. Creativity, when you have it, you don't decide it. It arrives. It's a moment, you feel it. And creativity brings you to ideas because it's not the same thing. And ideas is climbing all the time. So I climb with people to go to Africa to make this bakery. And then I climb with people in Geneva and he makes plastic. And I was like, but because I know as my technical skills that the energy of the sun is very high and we can make a lot of things. So I try to make this in the plastic was on the wave. People are very, very, very attracted.
Well,
Yes.
and I have to ask, and I'm sure I know the answer. That cassette-like thing you have with the chip in it with the information, that is not made in a 3D printer, correct? This is a mold that you make?
Exactly. So the process is step by step, going to the beach, selecting plastics, arriving home, cutting with the knife, not the knife, but the cutter, and
Mhm.
cutting for example, this side and
Sure.
this side. No traps. Cutting with no traps, making a little watch, it's okay, just very fast. Then cutting, put inside the tubes, melt the plastic inside the tubes, and then inject it in molds like this one.
There you go.
This one is braked. For the moment, it's very, I don't know what to say, it's very touchy because I broke the molds, I make a few pieces, but the solutions are here. I just need to make them.
Sure.
So is it with the 3D printing resin is a 3D printer, but not with the wire. Is a resin who becomes very hard, and you print with this, and you use it as mold.
Okay. So the mold you make with the 3D printer, but then everything that gets in there is just human power or solar melting for the.
Exactly.
Yeah.
Can I show you my screen?
Yes, please. Here. Oh, sorry. I've got to hit the button here. Second.
My first skill. What you see, because I see some things. You see the
Yes.
3D?
Yep. The tube and the tray and yes. Oh wow.
Exactly. So this, I have two patents in the most complicated watch in the world in 280. I was a 3D performer. And so this is the thing. You have the mirrors here. I make a geometry like the Toblerone in Switzerland, but it's very cool because I don't concentrate the light in a line. I concentrate it in all these surfaces. So the mirrors like this is okay, just two mirrors, because everything goes in the surface.
Yep.
And I use this cartridge and I use a probe. And to inject, the cartridge is push the plastic inside the mold. This is the mold.
Sure.
The mousqueton, I don't know the name of the carabinier, this thing.
Mm-hmm.
So everything is done by hand. I designed also a version with to put some wheels to make it really mobile. Because as I told you, I'm trying to develop these projects in the countries where they have tourists. Tourists in hotels is shampoo bottles. Shampoo bottles with the sun is money for people who's there. So we can make things with this.
Sure.
So that's the thing. I have also an Instagram a video of the process.
Sure. Yeah, before going to that, the is that a vacuum tube glass vacuum tube or okay?
This is a vacuum tube glass. The first when I was in Burkina Faso for the bakery project, I learned that this tube is going to be bigger, and then when they made it, I will directly buy some.
Sure.
There is a company named GoSun who make this
Yes.
in US. I don't know the size, but yeah, because the first glass is transparent and the second one has a copper layer was oxidized outside. You have a dark surface outside, inside the first level, in
Sure.
between the vacuum, because the vacuum has the direct and indirect light absorption, and also is a very, very good isolant. There, I don't know if you say isolants. One is for you don't lose thermal energy with this.
Right. So what temperatures can you get in there, and what does it take to melt the plastic?
Um, today, yesterday was half cloudy. It's like 40 minutes when it's more than 600 kilowatts, watts of sun. When you have
Yep.
650, it's like 15 minutes, 1 hour, you can reach 300 Celsius. In Fahrenheit, I don't know. Sorry.
That's in the 550, 600 Fahrenheit range. Yeah. Very hot.
Because the advantage of this one is because you know you have the big lens for LDAC, for example, or you have the parabols. You
Sure.
have the direct light and just like it's very hot, and now it's not more anymore hot. And this one is a very high isolation. It means you grow with temperature. You don't do like I have it, I don't have it, I have. You grow every time. Very
Sure.
very small. Sometimes when it's really cloudy, I really want to make an object because I like to make a different object a few times. It takes me the day. But for example, in this January in Portugal, I make 25 objects a day with a single object mold. It means if I make double object mold, I duplicate because it's my final goal is to make a real scale manufacturer to
Sure.
show the people there is people earning money, it's working, and it's just on the sky. Like And the way to make the machines, we try to make it, for example, the tube is the high technology and the rest is low tech. You need to do it like this because to export for Dakar, for example, or Burkina Faso, sometimes you need more time to fold some things than to put a screw because you cannot buy the screw. So we need to think things like only tubes, only things like this.
Yeah. And
Yes.
how long is that tube? What's the length?
It's like 0.6 meters.
Okay.
Yeah. I can show you maybe because I have models here. Like,
Oh, sure. Yes.
so we have this big.
Mhm.
Um, it's a good tool, but it can break if you forget it, for example,
Yeah.
because when you put the mirrors, they are not due for this. You put too much power inside.
Sure.
So
In fact, that was the one question I had is clearly you chose not to have the parabolic trough mirrors. That's because you don't need it. You get
I
enough.
don't need it. Go to the surface, not to the line.
Yes.
I
Yes.
need to, because it's vacuum, because vacuum makes the effect, don't do this, do, goes inside.
Yes.
It
Yes.
helps with this.
That's beautiful. That is just
Yeah.
beautiful.
It's like a magic tool. We need it now. We got it. So cool.
Yes. So you said you have a video.
This is my Instagram. You can see a video. But to say the thing is now I'm doing the number 2 version of the kit. Yeah, because this one don't have the brakes. You need to put some objects near.
Oh,
And
sure.
in the next part, I don't want to use this. I want to use only effect multiplication effects without the jack because the jack is you cannot have it everywhere in some countries.
Sure.
So if we go to my Instagram, like, and then I share you the Instagram on the page because I need to have more supply. I think it's supply in communication because making all the things, the 3D, then but I will find this. A lot of people in Portugal are interested in this and all the world. So yeah, here. Ta-da. So I need to stop share or change the share.
Oh, you should be able to pull up. Oh, yeah, you can
Stop
stop
the share,
and pick another screen.
reshare. Yes. So I make short videos to explain. So this is the version I have over my head, you know, on the rooftop.
Sure.
This is PP plastic. I put it inside the. It's important to compress the plastic. That's why I need to make another press.
And you don't
So
need to
this is
slice it up.
everything.
You don't need to
What?
slice it up either, right? You don't need to cut this up. You can just jam it in there, right?
Yes,
Okay.
because the process is with these tubes. You don't need to shred it all, too much. And when you go to the beach, some plastic breaks, and someone are like puzzles. So this is the part where I put the you seen the mold, and now I'm injecting. But it was difficult to film, and it was very funny because the effect was like cork, very strange because it was all the
Oh,
colors
sure.
of the
Yep.
plastic things.
Sure.
When you see the video is very basic, but the reality you need to learn some tips. You break a lot of things, and I need to share it. This base one you can do things. If people
Yep.
have aluminum molds, because the aluminum mold is the best, but is also the trap because it's the most expensive thing. When I make some events, for example, I went to we have a festival here named Catraya. It's very cool because they mix art science and sustainability all the same time on this place is very cool. So you show the things and people are, oh, very cool. This guy just take the waste and make objects. Yeah, this guy designed the 3D, make the mold, use the 3D printing to make the mold. No, 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 no. This way people don't see it.
Sure.
And is the most the mold is the most expensive. The part of the aluminum is like really expensive, very fast.
Sure.
Really?
Now, and are you part of a maker space in Portugal, or are you individual maker that happen to connect with the maker movement?
Uh, there is a community called Precious Plastics. I know them, but I want to be independent in the way to treat because it's with the sun. But there is all the makers who you are under them. They are very cool, and I don't know. I think about this sometimes, but because I just arrived 2 years now in Portugal, I met some people to make the sunglasses with lichen. The name is lichen. It was very cool. It was the first people who reproduct the system and use it. So I went near them directly to all the tips and do the things. So we make the sunglasses. We go further and further technical, and then I went to the maker fair and I won some. And the Portuguese high school are interested. I went to schools to share, and I'm in the talent. In the distributed design Europe is a big thing, and I'm trying to find my place in this. I'm going now in the lane. I want to say that, but I'm trying to oh this those one have this machine, those one have this ones. I don't want to be in one. I want to be giving things to anyone. Yeah, like this.
Sure. Uh,
Yeah.
any other videos there in your collection that you can share? Or
That's the problem. I have few things. I can show you because I can show, but in project mode, I have images. I have everything in the phone, the communication. Maybe I can show you some. I have articles. I need to share them. Instagram events, workshops, catalogs. I don't know where is it. We made some.
well, that's okay. One thing I have
I can
done
share the
with
pictures.
past, yeah, one thing I've done with past interviews is I will, with your permission, if there are other videos I see that are, for instance, I know there are one or two other people that have come up with something similar,
Yeah,
and
yeah,
be able to just say, okay, here's how great it is. You know, great minds think alike, as we say. You know, and
yeah,
so if I find something that has your, I could go to your Instagram account and like with your video, I can actually pull that up from the Instagram and overlay it in the final video for the forum, so that it's because the Zoom captures it pretty well, but not as good as the original, of course. So
yes, yes.
yeah,
So
yeah.
you tell me so maybe you were asking for originals. Is this?
That would be great. Yeah. I mean, if it's on Instagram, I can
We
probably
can try. We can try both. I do if how to say this. I know how to manage my privacy. If you see something on the web, you can use it. Just
sure.
you forget the credit is not a problem. You put the credit is cool. For me,
Yeah.
it's okay.
Well, it'll
Yeah,
be all in one package where you will be there, so it'll you will get the credit. That's
that's
great.
cool.
Yeah.
I can show you maybe pictures of objects that I made,
Sure.
the, the tries. So I need to stop sharing and resharing. Tac. But you see the big picture? No, you only see the because I
Oh,
don't share the
I see the
viewer.
whole the catalog and the thing with the it looks like dice with the nine dots. Yeah, that thing. Yeah, there we go. Oh, that's
This is a cookie for a cookie because people used to accept cookies. So I put the NFC inside and because all the objects because my mission is to valorize the waste of plastic. Is to use the less energy to do it and to valorize the maximum. So also with another project, you used to be in the crypto world and using NFTs, and you can sell NFTs very expensive. And because I put an NFC inside, you can
Wow.
open the plastic world to digital world and put art inside and things like this. So with the little caps, you can make like $1,000. This is the goal. I don't want to be rich, but to show people who can do it because I cannot do it. I'm not the artist who can make the thing who you can sell because I don't have the skills of artist. But the thing is this. So I make these cookies to people to share cookies. They accept information and they share cookies with each other.
Wow.
Because they are all different, you can make NFTs. Make also chocolates. This is the try. It's very difficult at the first try to have things really done. This is HDPE. And I will also make some rings. Rings is cool. The colors change. For example, this is a blue rope from the ocean. I I have always a Swiss knife because I'm a Swiss guy. When I go to the beach, I just got some ropes if I cannot take them. This is a rope from the beach. And I try to put the coordinates and people ask me, but if you put the coordinates, it means if you take plastic in another place, it's not okay. But the problem is there always enough plastic in this beach. So yeah, I put the coordinates. I cannot show here. I don't have all pictures. I don't know how to say updated for the coordinates. Sorry. Maybe here, you see here. I tried to put that. Is the beach where I go there.
Sure. And that's
Yep.
just a one euro cent.
This is a
That's
cent, yeah, because
beautiful. That is just I love it.
when I used to say to people when I see some objects in plastic on the ground, I used to say, I'm gonna invest 1 cent in this one. I
Yes.
think make some, yeah. But for me, it's a learning thing. The plastic is learning me things. Yesterday, I made these cassettes, and I went to see the phases of temperature in plastic, what happens, liquid, and I think I passed something. I inject at 235 centigrades. It was too much. I want to be in the 200, 180. Yeah. It's like a fire worker job. Like,
Yes.
oh, now it's hot. I need to go there. Make things. Yeah.
Well, and you mentioned different types of plastic. Do they each have their own
Ah,
temperature range, or how does that
yeah,
work?
this is important point, the type of plastics. We know as standards in international community, we have 7 kinds. These kinds is for different things. And they have different textures and things. You can recognize them. If it breaks, maybe it's PP. It's very difficult to break, and the color then is white, I think is another one. And with solar, I make a thing that we can make only 3 kinds. We choose only 3 kinds for some reasons. The most are those 3 kinds. And there's the LDPE, the plastic bags who stretch, not those who broke very easily. This is PP. And so it's LDPE, HDPE, and PP. Those ones don't bring gases and are very common and are easy to do. But the PP is the best because one is like mayonnaise, go inside around the objects. The other one is like a gummy, like a you can when you put it it breaks the molds and yeah. But only 3 kinds you can do it and the most common.
Now, for the materials you have for open source, do you list, for instance, I'm thinking I'm walking on the beach. Am I going to see, okay, there's a plastic cup, like just for beers or whatever,
Mhm.
or a water bottle, which of course are
Mhm.
just are insane to me that people actually buy water in a plastic bottle. But you're,
And plastic,
you,
we say is not yeah, it's not a water factory, it's a plastic factory.
yes, exactly. And And so do you have like a list of, okay, here are the objects you want for, HDP, polypropylene, whatever, and then along with those objects, the temperature range, or how does that work?
This is the work done by Precious Plastics, is a big community, and for my website, I just begin working. I need to speak with these people because they have all the knowledge about plastic. So I need to concentrate on the solar and share this. I don't have the ranges, but for the recognizing in the beach, I thought when I let me show you something. All these things comes from the beach, all the objects and things. I try to show how to recognize them, but there is a way to do, because at the beginning we were like, so what is this plastic? Is maybe we don't know. We need to buy a machine like a Spectrum, very expensive, I thought, like, if it's plastic, I can melt it, and it's plastic again. It's just the size of the object makes the object. I'm gonna do it. Don't need to recognize the plastic. It's in the comments. I'm gonna use it. The bottles, the PET, PET, the name of, not the transparent ones. This one I cannot do it with solar energy. This is the thing I was like, oh no, not those ones. But to to recognize, also you go to the web. For example, there is hunters, and there is a lot of, the red thing from the hunters.
Yep.
Something to make inhalation, or all the objects used on the beach are useful, and you can find all the time what it is, a lot kind of plastic. When you go to the web, you just say what is the material of this from the things, and it's PE. It's okay. Yeah, but I don't have a library, so it would be cool to find a library to have people.
Sure, sure. When you say not all plastics are easily re-melted and injected, there must be a way, but maybe there's just a whole nother machine that needs to be put up for that.
Um, all the process is make to make a solar injected plastic object. So when I make a document to show the comparison, we compare the industrial and the solar. The molds are transparent. The plastic ends inside, and the molds are transparent for a reason, because I need to see what happens. Because when I take the cartridge, I make a graphic. I know this graphic is like 65 seconds. If I take a 200, I have 65 seconds to make my job. Then it's too hard and it's finished. So if I see it, it's okay. Yeah, it's going, it's not. If I'm making some strength and it's not going, I need to stop. I'm gonna break everything. But this reaction is different a little bit with the type of plastics. If you use PP, it's very liquid. You have the fluid coefficient is better. And in the industry, not industry, even the solar precious plastic community, they eat the mold at 90 degrees. It means the plastic goes here and keeps the temperature, keeps going. In my case, the plastic is to do outside. So I cannot, because this is the cheap version of a mold. If it's an aluminum mold, it's more easier. And this to remind the plastic. So the PP is very easy. The HDPE is very difficult. It stays together. It's not liquid. It's like, to scratch the I don't know, the rubber. Yeah, it's like rubber.
Sure.
Yeah. It goes in the place, but don't go around the objects and broke the molds. So, and the range temperature is are the same. It's 200 for all. And yeah.
Is it possible to have, for instance, the plastic that's the easiest to use and becomes liquid with maybe a little bit of the other plastic in it? It's kind of like flake.
This is a problem. I just gonna bring some objects.
Sure.
I don't have it here. Is in another place. I'm sorry. But when you do your injection, I make a piston inside. And the way is to make everything standard. You don't need to cut, you don't need to weld. You just assemble to do the thing.
Sure.
So I buy some pistons to go here. And now it's very clean. And this is very important because at the beginning I didn't said like this cartridge is HDP, this one is PP, and when you mix the plastics, it it's gonna make like when you lose some, it's gonna be like hairs, like, and it's not good to mix the plastics. Yeah.
Okay. So you do have to keep them separate. You have to use one.
Exactly. And it's important to know the PVC because the PVC has chlorine inside, and then you have HO2, you have oxygen and chlor around you is not very good. It's very bad gases. Gas, yeah.
Okay. Now, have you made any solar cooker parts with this system?
Yeah, I have one here. Very cool. But um I decided because I just arrived to Portugal, as I told you. This is my cooker.
Hmm.
And I put, you can see this is, and you can change this,
Sure.
the mirror. It's like,
Oh yeah. Yes.
and you had some smart things. I put some QR codes and things, but this product, I put it aside now. I'm, I'm concentrated in the plastic parts because, and I have the plans of this one. If someone wants them to use, I share them. This one is very cool because it's like, I tried to make like, um, a young object, you take this, like the old box of music, you go to, I developed this when I was in Geneva. In Geneva, you have the Solemio, is a solar association, and I share with them, yes. But solar cookers, I would like to make the, I can show you maybe.
Sure.
For the molds, I would like to warm the molds since I'm doing the injection parts. Um, Ah, you're gonna like this one, I think. Yeah, I was trying to tell you that the food community, I just met some people here who are very, I call these people, they are strong, they are connected to the roots, and they want to live like me, like from the field directly to make vegetables in this. And I
Sure.
propose them to make a solar community because the oven is too expensive, the tube for them. So
Sure.
we met like 5 people. We spend a good day, and then the tube goes around, or the sun oven, and yes, it can be great.
Sure.
Yeah, you know this one.
Oh yes. Yes.
This one is cool. So the plans of this one exist everywhere, but I made it in 3D. Maybe I'm gonna make one with some people, but because the other one is more um, aggressive in time to use it, I don't know if I'm gonna develop this one. But for the molds, it can be cool. It keep warm. Yep. I cannot see you. Ah, you're here. So that's it.
Yeah. No, that's fantastic. Do you have other people that are reaching out to you to uh, get get lessons or tips?
Yep. Since I went to the name of the Maker Fair in Lisbon. I have people from Lisbon, Porto. Um, I have a lot of people want to do things with me in the workshops, and I have work to do, and I need to make the activities, to make the things, the planning, the agenda for the workshops. But I already have some with professional schools, but people are coming. They came, they want information. I call them, I send some real objects. And for example, Zagreb, that's so cool. This is in Croatia, and they told me that they want some. We will see if they have, because the thing is to have the money.
Okay. Yeah, I
Mhm.
can't think of anything, any more questions. I know I probably I'll go through I had a Word document with about 10 or 15 of them. I think I've asked all of them, but if I forgot any, I'll just email you and we can do a email exchange and also I can bring them up when we do the forum. But I see that we have, we're just short of an hour of material.
Yes,
This is great. This is perfect because I always have a little bit more and be able to condense it a little bit. I won't have to cut much because it's just the visuals are great and your descriptions were right on. So
thank
uh,
you.
yeah, this is fantastic.
We spend the time. I'm gonna tell you something. We spend this time, and I'm already melting some plastic now. Maybe it's ready.
Okay, great.
This is
Yeah,
my mission. My mission
yes.
is to speed it.
Okay,
Four parameters are very important when you do your thing. Is the thing you do, with who you do it, how much you win, and the gratification. But the real one, when you arrive at home and you are like, today I make something very good. Not the one when I make expensive watches and the guy says, yeah, you're making it the first time, very cool. This is not a real gratification. And I decided to make positive partnerships. It means if I work, because I made like 270 t-shirts difference to sell it in high price to make donation. And the goal was I'm working 8 hours today, but I'm gonna send $20 to Burundi is like 1 month, my 8 hours, my hour of work is 2 hours in an hospital. That's very cool. I like today what you did. I know did very bad things for the environment, but that's good things. And then you learn the last kilometer. When you send $100 and the guy receives 400, four. You say 10, you send 10 and they receive four. You're like, what happens? In some countries, you cannot send the money. It's difficult to help. Yeah.
sure.
Yeah.
Yeah. Well, great. Well, we'll let you get back to your creative work there, and
Thank you.
yes. Oh, thank you so much. This has been fantastic. It's like I say, it's on so many levels. This it speaks to me. You're using the sun. That's the whole idea behind my museum and the in the forum. So
Yes.
yes, thanks again. Okay, we
Thank you.
will trim this up. Great. That was our great conversation. I wish we could have stuck on for another few hours, but that's why we set up this forum. And Marco is here. And I had some people send me some questions by email because they couldn't make it. And I'll pull up that document here really quickly. Very good questions from all sorts of folks I've been working with. Let me find this. Questions from Marco. And I think some of them might already have been asked. Craig Berglund, who can't make it today, he's very interested in how to melt plastics correctly. He's tried to do it in solar tubes, but found when it cools, it cracks the tube. Well, he apparently put it directly in the glass tube. And also he did it vertically. So, and I think you described how you did it, but another question in the chat, I think, was about whether it's poured in or pressed in. And it sounds like you're pressing it into the mold. Is that right?
Yeah, that's right. It's because of the anyone can see me. I don't know if I have my camera.
Yes.
With the tubes, these tubes are the solution because when you use the thread, you can pull and push and it is on it. So with the jack, when I give my jack, I push inside the mold, yeah. So it's by pushing, yeah. It's okay for you?
Sure.
Yes.
Okay. And let's see. And which plastics you prefer? You listed 3 of them that you are able to use. It sounded like HDPE
Exactly.
was high.
The most common plastic we use is for elementary or for products. Is always some containers or some ropes. So if you have the containers like this one, this is from the beach, sorry. like this one, those ones like shampoo and all those things are HDPE, it's okay. Those for the food are PP and sometimes PET and the plastic bags. So the most common things, I have them, the most common objects, you just take them and they're those ones who came to the beach and then flies and you cut them and you go, this is writing on it, the symbols, but the good thing to know the plastics is to go near a precious plastics community. And yeah.
Sure. And I put that precious plastics link in the chat. So everyone that wants it, just make a copy or bookmark it. I know you mentioned the PET is transparent, and that's what you use for the mold?
No, for the mold, I use resin. It's a liquid.
Oh, right. Okay.
A UV liquid, and with a 3D printing, UV liquid makes the shape, this shape.
Sure. And you want it to be transparent so you can see that once it's filled, then you're done, right?
Exactly, because if it's cold and I make some string, I break this. And those ones are very cheap and very fast. You can imagine the object today and have it tomorrow.
Sure.
The plastic one, not this one. The real process, all the process in one day.
Sure. Craig also asked, I think it was Craig, if plastics could be cast in sand like they do with metalwork sometimes. Is that possible, or is that needs further exploration?
If you can compress, I think you can even do it with plaster or some things like this. But to have a good results of shine, of surface finishing with rocks, you're gonna have because the plastic goes everywhere. And I think you can do it. It depends on the object. If you're in a big object, make something, or I think it's possible, yeah.
Sure. When the last one is
the injection part. To inject in the rock, how to do it with pressure and don't break the rock, I don't know.
Okay. Takes practice. Yeah. Yes.
To make a cage, maybe.
Sure. One, Craig also asks, since plastics are machinable, do you have any tips for that? I imagine that most of it could be machined, drilled or planed and that sort of stuff. Do you do much of that, or you just kind of clean the edges when you make your mold?
I decide to orient in small objects. It means one injection is finished. So I just use the cutter, this one.
Sure.
And I finish by objects. When I was doing the sunglasses, you need to drill it. You need to make some things. Sure. But I have other projects from the future. People want to cast them. And I know casting is not that easy when you have not an homogeneous density product. So I don't cast them, but some big companies make the plates of recycle and they cast them.
Sure. Well, myself going back, and then we'll open up. Anyone can have questions. When you mentioned the glass frames made from COVID masks, and when we first, that went over my head, and I just realized that now, because that is a plastic that can be recycled. Okay, yeah, and
plastic is just perfect.
Yeah, they're the scourge of city parks. I can tell you that in Minneapolis, you take a stroll through the park, and the people that clean up the park, that's like probably half of their stuff. And through the last several months, it's probably going to go away to a degree, but that's so good to know, because they just seem to be such a common piece of trash. Yeah. Okay. Well, anyone else?
Yeah,
anyone
you can do like mushrooms.
Mm-hmm. Yes. Yes.
Okay. You can do like mushrooms. You have 15. You have glasses. It's a windy problem.
Yep. Well, one thing we can do, because a lot of people did ask questions in the chat and you covered them already. So that's good. I guess what I'd like to do is if I'll put it on the gallery view, and I'm going to go around and ask if anyone would like to introduce themselves just in the order that I see them. And then any question that you have, or describe what you're doing with solar energy and solar cooking. To Joel Goodman, who I've had a few emails from recently. Joel.
Yes. Hello. I've been working with a a solar cooker kitchen where the cooks can be in the kitchen, and it's like through a cookware door, they slide the cookware through into concentrators, reflective concentrators. And one of them is shaped like a CPC, the curved shape. It can be made out of blocks that support the reflectors. The reflectors may be aluminum or flat glass mirrors. So what I'm interested in is the possibility of using recycled plastic to support the reflectors in the CPC shape, the curved mirror shape. Can you 3D print recycled plastics?
Yes. In Geneva, there is the person who makes the first injection solar with me, and he makes like molds and he makes his plastic injections. But one of his projects is just incredible. It's like he takes the pots, the plants, plastic pots, broke, and they print them again, another ones. He made the 3D printers, and he prints directly the plastic, the recycled plastic. And he can make pieces like this, I think.
Is there any toxic outgassing in this plastic process?
There is in the PVC and ABS and some plastics. That's why we use only these three ones. But if you use plastic from a domestic activity, you don't have problems normally. If you use plastic from industrial activity, you need to be careful. So the most times, if you recognize the objects, this is a water bottle, this is, you know what is inside. And when you burn them, it's the PVC the most dangerous.
Now, in the plastics, the recycled plastics in your box cooker project, what's the temperature limit that the recycled plastic shapes can tolerate?
The plastics are made of different chemical components, and to have different family of plastics, you should change the order of some components. When you melt them, you run the temperature and you melt, but you make also a crystallographic phase. It means, for example, for the HDPE, this one for the bottles or for the shampoos, after 240, you change the composition of the plastic. And if you down the temperature like this, you don't have good results, or when you try to do it. So in my case, the rank is 190, 220, and I do all three kinds like this. Centigrades, you know, yeah.
So you're saying in your solar box cooker, your plastic, recycled plastic cooker box, you can reach temperatures of 220 Celsius?
300 more, 300 Celsius. Now at the moment, the plastic is 200. I don't know if you can see it. You see my camera?
Oh, yes. What?
This is 215. This is the plastic now, right now. The tube has a very good observation of the light, and
I'm asking about your solar box cooker made out of recycled plastic. Your
solar box. If we do with a solar cooker with plastic, if the plastic don't melt, is that the question? I'm sorry for my English.
That you showed your solar box cooker project made out of recycled plastic. Your last project that you showed, the box cooker.
Yeah, when the box cooker was just to warm up the molds.
But what's the maximum temperature? Oh, the plastic, your box cooker is made with recycled plastic?
Nope.
Oh, sorry.
Nope. You see, the box cooker is the one who opens, no?
Yeah.
Yeah,
well,
that's the shell, correct? The frame that you showed, Marco, that's the outside. That's not what's being heated up. You must have some other insulation for it.
You said the shell?
For the box cooker. Well, yeah, for the box cooker, not the tube that you use to melt the plastic, but you showed the box cooker.
Yeah, the box cooker is to warm up the molds.
Okay.
To make a good injection, because the mold, when you do the plastic injection, needs to be warm. So you can go in small tubes, plastic inside.
Sure.
Even if you don't do this, you just block your plastic.
And you're not heating up the mold to 200 centigrade.
No.
Just warm enough so
like
it's
80, 70.
Sure.
It's okay.
Is the box cooker made from recycled plastic?
Nope.
Oh, okay.
With wood and wool and aluminum and normal way.
Okay.
Sure. Okay. Well, great. Yeah, thanks there, Joel. I see next on my little grid here, Mark. I believe it's Mark Andis out in Texas.
That's right. Can you hear me?
Yes.
Okay.
Perfectly.
Yeah, this is Mark Andis. I'm from North Texas, Arlington, Texas, to be exact, right between Fort Worth and Dallas, Texas. Home of the Cowboys and the Texas Rangers.
Yeah.
I've listened to this with great interest. I give Marco much kudos for his trying to improve the environment. My interest recently has been in comparing and testing different pots, different lids, different combinations to see which can reach a higher cooking temperatures. Because as we all know, it's all about the power. And speaking of power, I have, as Luther has shown you in another video we did on me, I've made 2 solar trackers, and I just couldn't be happier. And I encourage everyone to look into that. It's not as hard as you think it is. Okay, it's not 100% easy, but it's definitely doable. And as one of the brainiacs in solar cooking, I forget whether it was Kurt Newback or Bernard Mueller or Dave Oxford said, the heat generation increases 30 to 40% using a solar tracker when you're constantly having the cooker point toward the sun. Thanks for having me on.
Thanks, Mark. Yes. And next on my grid is Paul Hedrick. I recognize Paul from a time or two interacting. What's up with Paul?
Hi, good morning. I guess it's still morning here anyway, where I am out in Seattle.
Yes.
And yes, it was a very interesting presentation. My background is primarily, I'm an architect, and I've been involved in passive solar homes. So a lot of the technology ideas about conduction, radiation, and convection sort of carried over. And I am now a part-time administrator for the Solar Cooking Wiki, adding information to that site. And I encourage everyone to take a look. I had a question for Marco, considering scaling up, doing larger versions of what he is doing. If there would still be a solar thermal application to do this on a larger scale, and then also the concern about the toxic off-gassing of the whole process.
Phone cut. Nice to meet you. Thank you for your question. It's a very good question. So because it's the way to me to have my sustainability to food. I need to live with this. So I need to make the big scale. So I already imagine my way. My way is in 3 years, having 15,000 pieces a year production. But to do it is not by growing the size of the machines, but by optimizing the process with number of ovens and number of people and number of molds. So that way we can do a lot, because plastic we have so much and is easier to transform. And I already make a plan to know how much I needed to be directly sustainable. And in this plan, the things are the machines, the people, and also the process. And as you to speak about gases, everything, some operations only outside, and some operations only inside. For example, for the microplastics, I have my own garden here. I don't want them here. So everything is inside when I put in the cartridge. Outside for the video, because it's better. But inside, the putting the plastic and all the burning in gases outside. And sure to don't have the PVC, this one will make the chlor. The other ones, it smells, but the gases are not offensive. These 3 ones. Yes. Did I answer your question?
Yeah, thank you.
Yes, thank you.
All right. Well, I got next up, I see another familiar face, Sharon, San Diego.
Yeah, so I'm curious, we do a lot of 3D printing, and I don't know if you saw the big red solar cooker thing that I printed and put up on Solar Cookers World Network. And we were thinking that thing took, like, for every little panel, it took us 8 hours to print them. And they're about yay big. And I'm thinking that with your method, that maybe we'd be able to mold it.
And do the sun with the sun for the sun.
Yeah, use the sun to make that. And so it really turned out to be a great thing. Nobody else had ever made it. It was on Thingiverse. It was called the Pocket Solar Cooker. And so it had all these things, and we built it, and then we found out it melted its own focal point. So I'm working on fixing that up. But what I'm thinking of is, if I were to actually use the molding, could I get as accurate? Because we have little things that are smaller than your fingernail that hold the pieces together.
It depends on the kind of plastic you use. You need to use PP.
It was HDPT.
It's DPE. This one is difficult to go inside the small surfaces. That's why when you take the plastic, sometimes you know directly the kind, because it's the only one who can make these thin surfaces is the PP.
Yeah, because like that's what I was saying, is the little chip thing is so small, it needs to be strong.
But I think it's possible to do this machine and make. This is the volume size of the cartridge, so.
That would make probably maybe
we can make bigger and make a few in a day. The thing is, if I don't have your project in picture, but if you have the geometries, and I can tell you something.
Yeah, it's you know, there's the free 3D printing site called Thingiverse.
Yeah, Thingiverse. Yeah, I know this one.
And so it's called the Pocket Solar Cooker.
Okay.
And I printed it just to see if it would work, and it's like 10 seconds, and you burn, a piece of wood. You can burn a hole in it. It's really well designed, and it's quite a challenge.
That's cool. Very cool.
One observation I have, Sharon, is you made it with a 3D printer where, because it takes so long, they probably made the specs so it was thin. But if with the mold, the thickness probably doesn't matter, so long as it's the right curve, right?
Yeah, the curvature.
Yeah. So maybe it might just work. You might need to, each piece has a little different curve though, right? So you might need molds, but each mold, melt for half an hour or whatever, and you could probably mold 2 or 3, and you probably get it all done in a day, as opposed to what, a week, or how long did it take?
Well, let's see,
Yeah,
we
that's
had
true.
36 6-sided pieces. And so each one took 8 hours. So it takes about 2 weeks to make it.
Yeah.
So you really got to be dedicated.
Yes.
But it means it means it's not a repeatable piece. It's raining here. That's why I'm moving from outside.
Okay.
Oh,
Sorry.
we're just
Okay.
overcast, May gray,
Yes.
waiting for June gloom.
Yep.
Okay,
Well,
that was what I wanted to ask about.
Okay, great. Well, and I see next on my little chart here, Sonny Miller. I believe you're at the other side of the world.
I'm in Western Australia, which is pretty far from anything.
Yes, yes.
But what I've been doing for probably 30 years is trying to convince people here to use solar cookers. So they think it's a great idea for the third world. And I say, well, the third world can take care of itself to some extent, but how about we just use these in our own backyards, keep the house cool because you're not cooking inside. And we have had people spend up to $400 for a solar cooker, quite an elaborate thing. But they operate them. Many of these solar cookers, they operate in the summertime because we don't have very much rain here. And then when it starts to rain, they put them in the garage and they never come out again. So I've been trying to teach people how to make a solar cooker that takes year 5 students in a primary school, 1 period, 45 minutes to make one. And that will get to 135 degrees C. There's no insulation, it's just reflectors. And so that's what my bag is. But I'm very much interested in what you're trying to do here, Marco. It's been very interesting watching you explaining what you're doing, and I wish you well. Very good. Thank you.
Thank you so much.
That's great. Just to reflect on what you said, Sonny, last fall, I spent 10 days at our state fair, the whole day with a Sun Oven Villager, the big, massive cooker, and a bunch of other cookers to demonstrate it. And that's the first thing people said, oh, it'd be great for camping, or it'd be great survival. And I did one of these where I just grabbed my hair. It's like, no, you can do it. You should do it every day at home when you have sun. It should be a habit. One of my, Sarah Mitchell in Utah, where a lot of the LDS church, they're very much into preparation. She says just about every one of her neighbors has a solar cooker, but when the power goes out and they want to cook, they come to her. How do I use this? And she says, you know, if you used it every day, this isn't an emergency. You know. So, anyway, well, great. Thanks so much for that. Next name I see, Jim Palmer, I think, right? Out in Albuquerque? Yes. Unmute there, sir.
Can you hear me now? Howdy. Greetings from Albuquerque, New Mexico. Right next to my buddy Mark right over here. Your typical solar guys, solar sun oven. I like cooked beans in that. I've got a 1 meter shiny disc, parabolic dish that almost burned my house down once. The thing that I've been doing solarly as of late is it's the solar chimneys that I put on a greenhouse that I just built. And I'm using it to be essentially an exhaust fan in the greenhouse, and also to draw air from a underground 600 feet of 4-inch plastic tubing buried 4 feet underground. So I'm cooling it with the cool of the ground. Anyhow, that's kind of solar stuff I'm working on lately. Good to see you, Luther.
Yeah, good to see you. I want to give a shout out to Jim for helping on the transfer of the Villager. the New Mexico Solar Energy Association's Villager Sun Oven. That was quite a task, and I'm happy to say my two young nephews helped to a large degree, maybe holding the chain for a while the thing was suspended in midair and all that. And Mark, of course, Mark Challam giving all the moral support as he was able to up in Santa Fe. Go ahead.
Andrew Stone.
Yes, Andrew Stone. Three that put their shoulders to the wheel, as it were.
Yeah.
And so I see next up then, well, if you're able to give us some words.
First, I really enjoyed this presentation. And what it really says is we are on the cusp of utilizing low temperature solar for industrial applications. And it can go forever. And that rhymes. All right, there's Jim with his solar tubes in front of his greenhouse. That's nice to see. Fantastic project. I was there. Works really well. I am a passive solar architect, and Paul, I'd love to talk to you sometime about passive solar and revising that around the world. I had a wonderful talk with a French engineer yesterday who also was in the revival mode of passive solar. So we do have something going there. As far as solar cooking, I've been doing it for a number of years. I've been playing with the villager that we've had here for, I don't know, 20 something years. Also deal with small solar cookers, designed and built different ones. I also play with biochar stoves and rocket stoves and race them against each other. And it's really been kind of fun. It's a new technology. And I'm really enjoying the biochar aspects of cooking that way. And that's it. I just love kind of hearing all this stuff, and I appreciate your work, Marco. And thank you.
Great, thanks, Mark.
Sure.
Well, Jim Palmer, now that you have that background up, say the word so you'll be the speaker in the frame for me anyway. There we go.
Nice, Jim.
So you can hear me?
Yes, and we can see the chimneys behind you. That looks beautiful.
Yeah, so the roof line is 8 feet, so those chimneys are around 13. And most of this was made with stuff that was reused materials or bought off of Craigslist. Those solar chimneys are some 16-inch round ductwork that I got from Restore. Stuff like the door hardware was new, but the glazing, but I've been using it on another hoop house for 10 years now, and it's weathered real well. And so I've got a pit in the middle and then fishies on this end. On the other end, I've got a super insulated room that I'll be growing mushrooms in.
Excellent.
Yeah, so I got inspired by a guy on YouTube, old fella Russ, 90-year-old retired postman, did greenhouse in the snow. He's in Nebraska and he's growing oranges in the middle of winter.
Nice.
Because in addition to being solar cooling, it's also solar heating, and it keeps things from freezing.
Great. Robert, if you want to unmute and turn on your camera.
Okay, well, I was very impressed with what Marco is doing. That's way beyond me, all that technology that he has, but very fascinated with that. And the reason I got into solar cookers was because I bought a wooden solar box cooker from Barbara Kerr and Sherry Cole in 1978 and started using it. And oh my goodness, then I started being a volunteer distributor for their eco cookers, their cardboard box cookers, which I'm going to be using today with one that's 30 years old or so. And it's going to be cooking chicken, rice, and asparagus because it can hold some. Asparagus is good. And but what I've since I left Solar Cookers International in 2009, and then formed a other tiny nonprofit, International Water and Health Alliances, that I've kind of shifted my focus then to eliminating waterborne diseases. And with Dale Andrietta then helped develop this water pasteurization indicator that is a simple product like that that has a wax that melts at 65 Celsius. You put this in water, you heat the water, and we do that quite often with a cook it and in a pot then. And when the wax melts and it falls to the bottom, you've reached 65 Celsius, you've pasteurized the water. And then being a microbiologist, you got to test the water. And so I put together this portable microbiology laboratory that has the coli alert test here, and it has the Petri film test that anybody can use and to test their water and see if it's contaminated with the fecal bacteria E. coli. And you do this before you heat the water, and after you heat the water, they're all killed. And it's evidence-based microbiology that this works. And that's where also then that my wife and I, through the International Water and Health Alliances, tiny NGO, that we support a project in Kenya with 70,000 citizens in Lower Nakach, Kenya. They don't have any improved water sources. They're all contaminated, but the women in the project, they do the microbiology testing. They show people that their water's contaminated. And then also they could solar pasteurize, but also we provide chlorine, some dilute chlorine they add to the water and kill the germs. So and for all of you people that are solar, you know, you really, it would be, I think, wise also to say, you know, I have a solar water pasteurizer that, you know, that people can use with a Whoppy to kill the germs, and it can also cook. And there's this wonderful website where you can get Whoppies from Bob Tate. It's whoppiesfortheworld.org. And I invite all of you that are solar people to also recognize how important it is, and you don't need to boil. You don't need to boil. Being a microbiologist, I knew all about that, and that's why we developed the Whoppy. And there are a couple billion people in the world that should know this, and maybe get a cook it to pasteurize their water using solar, and then they can also cook with that. Cook their ugali in Kenya with a solar cooker.
Okay, well, any last questions for Marco? This has been great. I mean, the conversation was great. The information, like I said when we first talked a few weeks ago, I am just so revolted by all the plastic in the world. But it's so great that we can actually recover some of it. And my dad was a pastor, so when I say you've redeemed the plastic, it's like te absolvo, te absolvo.
Yeah.
Like the priest saying, "Okay, you're forgiven, but now." Sin no more.
Yeah, no more. Yeah.
Great.
I just want to thank you a lot for this organization. Take the time to say thank you to everyone, because I have my book, and the projects you share with me were very cool, and I felt like being with experienced people. Thank you so much.
That's great. That's what it's all about.
I don't have a question, but I do have a comment. Last month, I was in the hospital.
Yeah.
And I realized everything in that hospital was made out of plastic.
Yeah.
The floors, the walls, the ceiling, everything they stuck in me, everything they stuck around me, everything I slept on. And they take this plastic and all go in the trash. But it was amazing that plastic is what saves our lives. So we need to understand that. We need to be frugal with it and utilize it as best we can. And, you know, not burn it. You don't need to burn it all. But I really appreciate what you're doing, Marco. And as I said before, we are on the cusp of industrial solar applications.
Yeah.
So It can go in so many directions. So thanks for being a pioneer in that.
Thank you. Thank you so much.
Sure.
Okay, anything else? All right, well, I'm call that a wrap. Or Sonny, did you have one more, or is that just waving? Everyone waving bye? Okay.
Everyone.
All right.
Thank you, Winter.
Thank you. Oh, this is wonderful. Really appreciate it.